Hello, students. For those of you absent, here's what happened in class over this past week. First of all, Mrs. Autumn is back, so we actually have to go over all the science-y stuff. The details, I mean. I'm far too busy to do it without her. On another note, you kids will hear these recordings a bit late due to some technological issues involving a strange substance we found covering the recording devices. A strange black goop. Speaking of strange, here's Mrs. Autumn.
Hello, kids. I'm back. Well, I've been back this past week. I was locked in a freezer for a bit a while ago. And you know what? If I find out who suggested that, I will give them a severe reprimanding. And by that I mean another worksheet for homework.
Ooh, scary. Anyway, let's just get into it. I am incredibly tired, but I have found out more about the disappearances.
Let's not do this again.
I'm sure it's one of these. You just give me a moment. Oh, nope, that's not it.
Monday we learned that most substances in their solid form are more dense than in their liquid form.
Molecules are more compactly squished together like teenagers on the last bus out of town.
Yes, however, water has a strange property where the molecules actually get further apart when they're solidified. This makes it so the ice floats on top of water instead of forming on the bottom. Because of this anomaly, when winter comes and ice forms on the top of lakes, the mermaids and pufferfish can still survive under the hard surface. It also plays a part in the erosion process where water seeps into the cracks of the concrete, freezes, and then makes the crack even wider. So now you know who to blame the potholes on. Water! Ice! Stuff!
This week we also worked more on solids. There are two main classifications of solids: crystalline solids and amorphous solids. We called on Crystal to give an explanation of crystalline solids. Thankfully, the prompter in the back of the classroom told her what to say, so Mrs. Autumn and I shared her seat as Crystal took charge of the class.
Crystalline solids are solids whose atoms are in an organized pattern. We found a strange blue telephone box outside and decided to put as many dodgeballs in as we could to show the ordered, tightly packed representation of crystalline structures. However, the balls just disappeared. And a few moments later, and a weird sound later, so did the telephone box.
So now our school has no dodgeballs and we'll have to go back to throwing pineapples at each other. The smallest portion of the crystalline solids is known as the unit cell, like a single tile on the floor of the bathrooms. There are 3 different types of cubic unit cells, 3 different kinds of patterns that could be formed. The first is a simple cube, where the atoms form along the vertices, the outside corners, of the cube. So we painted black dots on the corners of a few dozen of the tiles. The next is the body-centered cubic unit cell. This is where there are molecules at the corner of the cube, as well as one that is in the center. See? Body-centered.
Like a monster, where the head is the center of the body, and it has 8 limbs, 4 that reach up and 4 that reach down, and it can travel on walls and underwater and devours small children 4 at a time when you...
Don't forget it on the quiz.
The third type is the face-centered cubic unit cell, where molecules again are at each vertex, but it also has molecules on each face, the flat surface of the cube. While the tiles are flat, not 3-dimensional, we still did our best to paint them as if they were. Blue dots on each corner, yellow dots on each center.
We got about halfway down the hall before the lookout spotted the principal coming and we had to return to class. From what we gathered, he got after the art class, not us. Since the art class was canceled this week, we obtained more students into our class, just in time to learn about amorphous solids. Unlike the order that crystalline solids have, amorphous solids are more mishmash, squish-squash, wibbly-wobbly types of structures, made by man. That's why they're called man-made, because if a woman had made those same materials, they'd be crystalline for sure.
I don't think that's how chemistry works.
Of course it does. Hush. In these types of materials, molecules are more randomly connected, and this causes several interesting problems that most materials don't. First, they do not have distinct melting or boiling points. It's more of a range that temperature affects them. Guesswork. Second, when they break, they form strange shapes. Unlike when you snap a twig and get two pieces, more or less broken in a straight line, broken amorphous solids have curved shapes or weird pentagons in some places.
So we went to the lab, the cooking lab that is, and started making some of our own materials. First, we attempted to create glass by adding silica sand, sodium carbonate, calcium oxide, lead oxide, and iron oxide together and turning the gas stove on high.
After a minute or so, we guessed that it wasn't hot enough, so we maxed out the oven temperature and stuck it in there. 3 more minutes of watching and waiting led to nothing, so we started to add lines to one oven to get the temperature up to the desired 2300 degrees Celsius. That's when the fire department stopped by and ended the experiment. And that's about it. Homework this week is to make some of your own amorphous solids to bring to class on Monday. That can be rubber, plastics, fused silica, or glass, if you can avoid the fireman patrols. I was unable to find the notes I had on the disappearances, so I'll let you know.
Or you won't. And we go on with life. So, blah, 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 be safe, blah, 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 be careful.
Be safe, be careful, travel with a friend. We'll see you next week.